Hello, I'm Karel from Pair Trading Lab. Today we are going to look a little bit on Kalman Filter and its application on pairs trading. So to start, I guess you already know about some basic models you can use for pairs trading. We can, for instance, take a look on a residual model. For demonstration, let's use Visa Mastercard pair, and I will demonstrate how Kalman Filter can improve your pairs trading performance when applied instead of ratio or a residual model. So let's see. Let's first try residual model with default parameters. Okay. Let's keep it for last 3 years. And we can let the rest of settings like it is, I think. Let's lower the entry threshold a little bit for this case. Yes, so with using residual model at this Visa Mastercard pair, you can say we get something like 6% of CAGR. You can notice this pair exhibits quite high positive correlation of 0.95. How this model works? Basically, this simple model is trying to do the linear regression with floating window of period, in this case 15. You can see here. And using this regression, it tries to figure out optimal regression coefficients, which actually determine the balance point of these two equities. This is, you can see that this pair is mean reverting and it kind of works, but this is not really impressive performance. We can try to play with parameters somehow. We can try, for instance, to decrease the threshold a little bit. Maybe we gain more trades in this particular case. No, it doesn't. It did not really help. Yes, with this, we can also try with ratio model. I'll put it back. Just let's try with default parameters. It's even worse. Yeah, it has periods where it makes money, but we can see both models have quite a problem of exploiting statistical processes in this particular pair. So to address this problem, we will try to apply Kalman filter to determine the balance point or the regression coefficients of this pair, which are coefficients beta and alpha, which determine the linear relationship between Visa and Mastercard. So let's try first put Kalman with default parameters. We will see what it will do. This will be better to keep too simple. So now we can see it's mildly better than the residual model, but you can see there is really low amount of trades. And you can see the probably from this chart you can see this is supposed to be the entry threshold for the strategy, but you can see it's too wide. It doesn't really catch many trades. So we can just attempt to decrease the entry threshold, for instance, to 1. Now we are going somewhere. Yeah, we got 9% of CAGR and quite a lot of trades. So making use of Kalman filter for this particular pair actually makes sense. The problem is, first, the reason behind this might be that when compared to residual model, which just fits the line between price points, and it tries to figure out the linear relationships between two equities. The Kalman filter is better because it also tries to predict the balance point, the regression coefficient for the next sample, next day. So just because of this, using Kalman filter should be more precise to using just residual model, just because of this fact. Yes, that it's better in figuring out the regression coefficients. But unfortunately, Kalman filter has quite a problem, and the problem of Kalman filters are few parameters. Namely, it's the transition covariance delta, which together with observation covariance VE, they determine a lot of behavior of these Kalman filter based strategies. The reason is these two numbers actually create initial setting of the Kalman filter, which would determine its further behavior. The problem is that these settings are, at least the first one, the delta, is quite sensitive. Yes, we need to somehow figure out these values. So let me check. Let's do it again, the backtest with these parameters to keep it open. Now I will try to do the same backtest with slightly different parameters. I will first try to do it with different observation covariance. Let's see how it will differ. This is not really too different, considering there's almost no difference. Yes, you can see it's almost no different, considering that actually I tripled the value. So this is not really a problem with these parameters. VE is not a real problem. But now if I will try to do something with observation, with transition covariance, let's for instance divide it to 10, multiply it to 10. Now you see the results are totally different. Yes, almost no trades, and you can see the entry threshold bands are just too wide to do anything. Yes, now we can just put some another value. Let's just divide it by 2. It's a little bit better. Yes, it's a little bit better, but still not good. So now when I will just divide it by 10, for instance. Now this is very interesting. Yeah, good amount of trades. But the problem is that it's very difficult to apply Kalman filters for pairs trading just in this simple way, because of exactly this problem of figuring out these coefficients. Or mainly we can just forget the observation covariance VE. That's not really big deal, but the real problem is this transition covariance parameter delta, which is quite difficult to tune. Also, we can probably use some optimization technique to figure out like the most optimal value of this coefficient. But then we have problem because we will need to fit this optimization on some historical data, and this optimal solution will probably drift anyway with time. So to address this problem, we made our research and we developed two complex models based on Kalman filter, which actually solve this problem. Okay, so to demonstrate, there are two models we invented to address this problem, and that's Kalman Grid in version 2 and Kalman Auto. Kalman Auto is simple version, or from these two it's the simpler one. Kalman Auto works in the way that it's, instead of just evaluating one Kalman filter with one parameter delta, instead of this it will execute many strategies, many instances of Kalman filter at once, and each Kalman filter distance, each Kalman filter instance has different delta as a setting. And basically there is some advanced algorithm on top of this cluster of Kalman filters, which is switching between these Kalman filter instances based on some rules. In this particular case, I only have two parameters for Kalman Auto model, and that's the usage target and observation covariance. So you can see the observation covariance VE. This is just the same setting we used to see for the Kalman filter itself, and it's just passed to all the instances of Kalman filter like it is. Yes, there's nothing different. Luckily, this parameters is not really that sensitive, so we can keep it in this value. And now this is the important parameter. This is the usage target. The usage target is the hint for the optimization algorithm, which is the algorithm switching between these Kalman filter instances. It's the actually slot usage target. That means if I set this particular usage target to 60, it will try to switch between Kalman filters in a way that in average the strategy is in position in 60% of the time. Yes, so let's say if you trade 100 days using Kalman Auto, and if you set usage target to 60, the algorithm between selecting between these Kalman instances will try to optimize the switching process, so at the end, after these 100 days, your strategy spent 60 days in position. So let's try it, for instance, in this setting on Visa and Mastercard pair. As you can see, this is quite good performance. It already boosted the performance to 11% of CAGR. Yes, and here in days in trade, you can find that this strategy spent about 50%, 55% in position in total. Yes, so you can see it kind of works. It tries to optimize the process, so it's going close to 60%. This is kind of good, I think. And you can see the performance is quite nice, considering it spent only 50% in position. So we can also try to boost it a little bit. Let's put 70. So you can see now the performance is even better. CAGR almost 14% with quite a nice equity curve. You can see linearity is about 90%, and it spent 65% in the position. It's kind of good performance, especially when comparing to ratio and residual performance. It's like more than tripled. Yeah, you can see that. The good idea, the good thing on this is that this model is the optimization process. It's profit agnostic, so it doesn't do anything with the profit, really. Yeah, it's just the only thing it's trying to do is to match your usage target. So it's good that if you trade some pairs which don't have which have periods of not good performance, it won't really fool the model to do any decisions. One more thing, this Kalman Auto model actually optimizes not only your delta parameter, but also your entry threshold. So this is good. That this it's very significant advantage of this model is that this model is actually almost parameterless. The only significant parameter you have to set is your usage target. There is one more model we have. It's called Kalman Grid version 2. This model is compared to Kalman Auto is more complex. This model doesn't optimize for some usage target, but it just tries to optimize for the best performance. Yes, it optimizes not only delta, the transition covariance, but also the VE, the observation covariance. But it doesn't really optimize entry threshold. The entry threshold you must figure out yourself. Basically, with entry threshold, you just specify, or you can affect how many trades this strategy will do. Good range is between 2 and 4. So for instance, let's take number 3. Let's take entry threshold of 3, and let's test it. So you can see the performance is also much better than ratio or residual model, at least for Visa Mastercard pair. But on the other hand, you can see that since the last third of the time, the performance start to decay. Because this model optimizes for best profit. It can be fooled when there is a time period where your pair is not really performing well. So this is the disadvantage of this model. Yes, but you need to always experiment and try. I always suggest to try both these models to see for this particular pair which one works better. We can try now to analyze the Visa Mastercard pair. Hopefully it will tell us which model is works best. And we can compare which one is better. So yes, we can see you can use this profit analysis. We can use for that. You can see like the best performer is Kalman Auto model with usage threshold 70%. If we just change the margin to 50% like the backtest did, so we can see this is the best performance. So for Visa Mastercard, Kalman Auto model just performs the best. So you can see for at least for Visa Mastercard pair, Kalman Auto performs just the best. You can see it's almost twice as better than other models. Yeah, you can see this is the some residual model with really long period, I guess. Yes, it's period 45, and it's not really close as good as Kalman Filter. Yes, for this pair. Kalman Grid doesn't perform that good, but still better. Still better than any other models. Yeah, we can see it here. Yes, so for this particular pair, the Kalman Auto model is clear winner. Yes, no doubt. Okay, let's now try with some different pair. For instance, LQI with VNQ. They are both rate funds, reality estate funds. Like Visa and Mastercard, this is one of pairs which still seems to work. There is the mean reversion. So we can see, looking at profit analysis, that for this pair, Kalman Auto models don't really perform good. And for this particular pair, they perform much worse than other models. Yeah, this is like the best performer, which is quite poor performance. So for some reason, the Kalman Auto doesn't really work good for this pair. But you can see that actually Kalman Grid models are on the top. As you can see, it's close, but Kalman Grid model with threshold 2 is the best performer for this pair. Yes, nice and smooth equity curve. When we set the margin to T margin, you can see like the performance is very nice for this pair. Yes, at this analysis we can see the difference is not really good. The difference is not really great, but it's still the best considering there's virtually no parameters. And you can see, this is quite important, that these symbols are Kalman grid backtests. This one is with anti-threshold of 3, this anti-threshold of 4, this is anti-threshold of 2. And you can see all these combinations are at the top. Yes. So this, for instance, this strategy is in the in position at 65% of time, but still like perfect looking equity and good profit. You can say, you can see with 50% margin, this pair is doing 23%. So this is important to see that even with different parameters, these models are, these particular strategies are just on the top. Yes, you can for sure you can see here model which has close performance. This is the RSE based models. This is residual model. But with all these models, you have to tune parameters. Yes, and you can see there are really, for instance, between this model, this is ratio and this is ratio with different parameters, there are really big difference in the performance. But you can see in this case, the Kalman grid strategies are all of them at the top for the Kalman grid. Yes, so you can see from this example that some pairs work just good, work well with Kalman grid. Some other pairs work great with Kalman Auto. You need to just try for yourself and decide. So I hope now that you understand more about why we just came out with these advanced models based on Kalman filter, because in many situations they just outperform any other modules like ratio and residual. On the other hand, they address issues we have with Kalman filter, because Kalman filter just by itself has some parameters like transition covariance delta, which is quite sensitive to be really used in for real trading. You will have to optimize this parameter using historical data. This is what actually we want to avoid. So this is why we just came up with Kalman grid and Kalman Auto models. They just optimize these parameters like online, just as time goes, using some machine learning algorithms like weighted majority algorithm. So you can already use these Kalman filter based models in Portfolio Manager. Let's just make some small portfolio demo with 2 slots. So I'll just put there our Visa MasterCard strategy. That was Kalman Auto with usage target of 70, for instance. You can see like with these strategies you don't need to really worry too much about parameters, because basically the one parameter you want to tune is here is the usage target. Well, now we add the LQI. P and Q. This is basically arbitrage between 2 reality estate funds. We will use Kalman grid here with threshold of 2. Now we can leave it like this. So let's backtest it for the same period. As you can see, it works as it should. We can even try to include one more pair. For instance, let's try another real estate fund called National Retail Properties together with Realty Income Corp. Now in this case try also Kalman Grid. For instance, in this case with rent threshold of try, let's check it out. So now we have 2 slots and 3 pairs. You can see it boosted CAGR. Yeah, we now have 2 slots and 3 pairs. Please don't use this for real trading. You need at least 10 slots to diversify properly. This is just a demonstration like that these 3 Kalman filter based strategies just share 2 slots. So this is just example. All these, or both these models, Kalman Grid and Kalman Auto, are fully supported since PTL Trader version 1.4. So you can fully, at this time, you can fully take advantage of these models in your trading using PTL. So I hope you find this tutorial a little bit interesting, and I just wish you good luck with your trading. Bye bye.